Hello class and welcome back to Algebra 1B Bootcamp. We are now working on solving linear equations and linear systems. Whenever we're solving a linear equation, just a basic linear equation, all we want to do is get x by itself. You do that by first moving any addition or subtraction. So here I would add 3. The 3's cancel from here. And 13 plus 3 is 16. Then I divide to undo the multiplication, so x would equal 4. There are several properties involved with solving equations, like the distributive property. If I have this -3 out front, I want to multiply both numbers in the parentheses by -3. And now I solve it like a normal equation. I add 6. Then I divide by -3. In this particular situation, I will distribute the -3 again. So I have -3 times 1. And then it will be minus -3 times 6 is -18x equals 14 minus x. Then the next thing I want to do is combine any x's. So since I have an 18 here, an 18x here, and a -x here, I'm going to add the 18x over to the -x. And I have 17x. The 14 stays the same. And the -3 stays the same. Then I'll subtract the 14 from both sides because 3 and 14 are like, and we want to get those together. Then divide both sides by positive 17 to get x by itself. And I have x equals -1. That's enough linear examples. You can try the next 3 on your own if you would like. Now let's talk about how to solve a system of equations algebraically. There's 2 really different ways to do it. You can do it algebraically or you can do it graphically. I'll show you 2 different algebraic ways and then I'll show you a graphing way. The first way is known as elimination. Whenever we're solving using elimination, we want to manipulate the equations so that a variable eliminates or goes away. So we are looking for, pick a variable that you want to get rid of, and we want the numbers out front to be the same but have opposite signs. So looking at this, it really doesn't matter which one we work with. Let's look at the x's. Let's try to eliminate the x's. So I want these 2 numbers to be the same. I make them the same by multiplying. So I will multiply this first equation by 5. All things by 5. So 4 times 5 is 20. 5 times -3 is -15. And 5 times 8 is 40. Now look at the second equation. I need the same number but opposite signs, so I will multiply the bottom one by -4. Again, I'm trying to make both numbers be 20. So this is now -20x, positive 8y, and then positive 44. Now I add. Always make sure your columns are lined up so your x's are together. They cancel. -20 plus positive 20 is 0. I have -15 plus 8, which is -7. And then I have 40 plus 44, which is 84. Divide both sides by -7. So y equals 84 divided by -7 is -12. You figured out your y's, but you have to go back and figure out your x's. So take this -12, and you need to plug it in somewhere. It doesn't really matter. I usually pick the one that has smaller numbers and less negative. So I'm going to plug it in all the way back in the beginning to 4x minus 3 times negative 12 equals 8. I have to do the negative 3 times negative 12 first, which is 36. Then move the 36 over by subtracting it. Cancel. I have 4x equals negative 28. And negative 28 divided by 4. So I get x equals negative 7. So that's my answer. X equals negative 7 and y equals negative 12. Depending on your situation, this might be written as a point. It would be the point negative 7, negative 12. Now, you can also solve by substitution. When you substitute, you want to get a variable by itself. It doesn't matter which one. You always want to try to pick the easiest. You want to avoid ending up with fractions. So in my situation, I'm looking at this top one. It's very easy to get either x or y by itself. I'll just subtract my x from both sides. So the x is gone from here, and I have y equals negative x plus 2. Then I take that, and I plug it in for y in the other equation that I haven't messed around with yet. And I'll rewrite 2x plus 7 times negative x plus 2 instead of y equals 9. I'll distribute. And combine some terms. 2 minus 7 is 5. Then subtract 14 from both sides. 9 minus 14 is negative 5. Then divide both sides by negative 5. So x equals positive 1. I'm not finished. I need to plug positive 1 back in somewhere. Again, I always like to pick the equations that have very little negatives, anything like that. So I'm going to plug it into the top one. Instead of x, I'm going to write 1. So it's 1 plus y equals 2. Subtract the 1. So y equals 2 minus 1, which is 1. So my point is 1, 1. Now flip your paper to the back. If you're looking on the back, we want to solve the system by graphing. Technically, you can solve any system by graphing. It doesn't matter. All you have to do is get y's by itself. So this first one, y is alone. The second one, I need to move some things around. So I'm going to subtract the x. So I have negative y equals negative x minus 10. Then divide both sides, or divide every number by negative 1, because you have to get y totally by itself. So negative x divided by negative 1 and 10 divided by negative 1. Okay. Now you're going to go to your graphing calculator and punch it in, or you can graph it using y equals mx plus b, whichever you prefer. So if I'm going to put this into my graphing calculator, I go to my y equals, and I'll punch in negative 4x plus 5. And then I'll punch in x plus 10 for my y2. I really want to see where these two graphs cross. I'll give it a second. The blue line and the red line, I want to see where they cross. Sometimes it's easy to tell, sometimes it's not easy to tell. You can always turn on your grid lines to kind of help you, like I have mine turned on here. If you need help doing that, let me know. I can assist you. But the two graphs cross at negative 1, positive 9. So that's the point you would write down. And we have already done systems of inequalities, so we don't need to worry about that again.